Okay, so we know that in this problem, Clint Dempsey from the United States soccer team kicks a soccer ball so hard that it actually goes into a geostationary orbit. Now, obviously, this is drawn to scale, but we know that the ball is orbiting the Earth at 3.6 times 10 to the 7th meters above the Earth. Now, we know that in this problem that there's only one force that's actually affecting this ball, and that's the force of gravity. And we know that the F net is always equal to the mass times the acceleration. Now, the F net, since the only force that's acting on this object is gravity, we know that the F net is going to equal the force of the gravity. Now, we actually have an equation for the force of gravity. We know that G times the m1, which is the mass of the Earth, times m2, which is the mass of the object, over the radius squared will give us the force of gravity. And we just make that equal to mass times acceleration. Now we also know that acceleration in a circle will equal velocity squared over the radius. So we're just going to set this force of gravity and then mass times velocity squared over r equal to each other. Now we know that what we're looking for in this problem is velocity. So we can just use algebra to solve this for velocity. So the first thing we're going to do is just get rid of this r by multiplying it by the other side. And we know that because this is divided by r squared and this is multiplied by r, we know that the r that's being multiplied is going to go away, and we're going to end up just with r on the bottom. So once we have that done, we end up with g m1 times m2 over r equals mass times the velocity squared. Now we're just going to go ahead and divide this by m, and we're going to end up, this mass is actually the mass of the ball, which is the same as this mass, which is the mass of the ball, so those cancel out. So they're not even going to factor into this problem, and we're going to end up with g times m1, which is the mass of the Earth, over r equals velocity squared. Now we're just going to go ahead and do the square root of this, which will give us v. Now we know that it's going to be the square root of g times m1 over r, but actually r is not only the radius of the Earth. It's the radius of the Earth plus this height they give us here. So it's the radius here plus here. So we know we're going to have to add these two together here to get that velocity. So another thing that we know is that g is a constant on Earth. We know it's always going to be 6.67 times 10 to the negative 11th when on Earth. We also know that the mass of the Earth is 5.97 times 10 to the 24th. So we're just going to go ahead and plug these numbers in, and we end up with g times m1, which is 6.67 e to the negative 11th times 5.97 e to the 24th. We're going to put that over the radius of the Earth, which we know is 6.37 times e to the 6th, plus the height that they give us right here, which is 3.6 e to the 10th. And just through algebra, we can solve for v, and we end up with 3,606 meters per second that the ball is traveling around the Earth in a geostationary orbit.